Let's look at the solution to this problem. So we have y equal to x plus 2 over x cubed minus 1. Let's see how we can find the derivative. This is Namakando Academy. Thank you for watching this video. So now we have that y is equal to x plus 2 over x cubed minus 1. Now if you look at the arrangement we have here for y, this is presented as a quotient where you are dividing x plus 2 together with x cubed minus 1. So let's see how we can go about it. Since there is division involved in this arrangement, or rather the function y is presented as a quotient, it means that we are simply going to use the quotient rule method of finding the derivative. So if this is what we have, our dy dx will be v, then u prime minus u v prime over v prime. Oh, sorry, this will just be v squared. Now, which one is v? Which one is v and which one is u? So what you do is this. From this which we have here, our y, you're going to let x plus 2 to be u, x cubed minus 1 to be v. The one which is the numerator is going to be u, and the one which is the denominator, x cubed minus 1, is simply going to be v. Then we'll find their respective derivatives. Let's get started into it. So we say that u be equal to x plus 2, the numerator like I've stated, and v be equal to x cubed minus 1. We've identified the two functions u and v. What we now need to do is to simply find their respective differential coefficients. So if u is x plus 2, u prime or du dx will simply be, by use of the power rule, this will be, upon differentiating x, will simply yield to 1. Then this being a constant, differentiating a constant simply gives us a 0. So this is our u prime. Our v prime will be equal to, differentiating this one to give us 3x squared. 1 upon differentiating it gives us a 0 because it's a constant. Now we found everything we need for our formula, which enables us to find dy dx. So now let's substitute. So dy dx will be equal to v, which is x cubed, minus 1. This one is going to multiply with the derivative of u, which is 1. Then say minus u is simply x plus 2. This one is to multiply with the differential coefficient of v. Differential coefficient, as you can see, it is 3x squared. After this has been done, we are advised to simply divide with the product of v together with itself. So v and v will multiply, hence v squared. So we're going to simply square v. Function v will be squared. This will be x cubed minus 1, everything squared. Alright, so let's do the expansion. Now, before we expand, this can still be presented as dy dx is equals to, since what is inside brackets is multiplied with 1, we can just write x cubed minus 1. Then this side we say minus. We can position this 3x squared at the beginning, then we end with x plus 2 in brackets. Then we say over x cubed minus 1 all to the power 2. Alright, let's get rid of the brackets which we have here by simply expanding. That is by multiplying with 3x squared, which is negative here. So this gives us dy dx to be equal to x cubed minus 1 minus, now when we multiply 3x squared times x, it will give us 3x to the power 3. Then negative and positive, this one will give us a negative Then 3 times 2 it gives us 6x squared. Everything will simply be divided by x cubed minus 1, then raise to the power of 2. Okay, so this x cubed and that 3x cubed, which is negative, will simply be grouped together, which can just simplify them the way they are. So our dy dx will be equal to x cubed minus 3x cubed will simply give us negative 2x cubed. Alright, now followed by that, we can write negative 6x squared first, then we end with negative 1, not forgetting that this is being divided by x cubed minus 1, everything to the power 2. Now from what you have on top, you notice to say the negative is common, hence you have to factorize the negative. This therefore gives us our dy dx to be equal to negative factorized. You now have 2x cubed, then plus 6x squared, then plus 1 over x cubed minus 1, everything to the power 2. So it's not a necessity for us to simply expand v squared, hence we'll have this as our final answer. Thank you. Please consider subscribing, sharing this video as well. Thank you very much. See you in the next video.